Good morning, everyone. So in the last class, we are trying to discuss with exception handling here, and so we identified here. So what are the different types of exception we are having, and how we are going to work with try catch block, and the remaining keywords called throws and final keyword here. Okay. So up to the yesterday classes, we covered with exception handling, and today we are going to discuss one of the important concepts here. So basically, exception handling also one of the important concepts we discussed. And today onwards, we are going to work with one more important concept called multi-threading here. Getting the point? So multi-threading concept. Basically, so what exactly this particular multi-threading concepts are going to work in Java language here, right? So basically, whenever we are whenever we are having two types of works here. Those two types of works are going to work with simultaneously. So using our multi-threading here. So if the multi-threading is not available here, now what we need to do? So basically, we need to work with one by one. So we need to work with one by one here, getting the point. And if you observe carefully here, we are having one task here, and one more task we are having here, right? And from here, now what we are doing here, we are trying to run this particular task here. We are trying to run this particular task here. If this particular task is completed, now what we are going to do? Again, we are going to run this particular task here. Right. And here, using this particular multi-threading concepts here, now what we are doing, what we are going to write here. So we are not going to wait to complete this particular first task here. Getting the point? We are not going to wait to complete this particular task. So simultaneously is nothing but, so directly one thread is going to run for the above task, and another thread is going to start for the below task here. Getting the point? The simple example here, so while compiling our code, now what we are doing here, we are opening our text editor, or we are moving into the any website to find out the such information here. Getting the point? At a time, we are trying to work with the simultaneously, two or more than operations we are doing here. Like how we are going to run with the help of this particular thread concepts here. Getting the point? So this is very important here. Basically, by default, each and every operating system will have multi-threading concepts here. So how we can understand here? Now we can see what I am doing here. I open one MS Paint here, and this is a one thread opening the MS Paint, and another thread. What we are doing here? We are trying to design something on the particular MS thread. Getting the point? Along with this, now I'm moving into the edit place. So now you can observe how many threads we are trying to work here. The Notepad++ is our one thread, and MS Paint also is another thread. And on top of this particular MS Paint, we are trying to write, like we are trying to design something. This is the another thread. Getting the point? So these are the threads are working simultaneously, or parallel operations we are working here. Right. And here what I want to provide in our Java language, this particular multi-threading concept is provided by default here. Like it's like a built-in program. We can call it as this is the multi-threading is a built-in program here. And using this particular multi-threading here, now what we can do? So we can run two or more parts of the our application we can execute simultaneously, or we can run concurrently. Getting the point? And each part of such a program we are going to call it as a thread. Getting the point? If I'm going to run two or more parts of our application, now what we can call it as a each part of the particular program we can call it as a thread. Right. Same thing, the simple example here. This is the one thread, and Notepad++ is the another thread. And if I'm going to work with IDE, this is the one more thread. Getting the point? So these are the different threads we are working on the concurrently, right? And here, what we can call it as each thread is going to define. Getting the point? Each thread is going to define the separate path of execution. So it's not going to define it's not going to depends on the other thread, or all the threads cannot work with the same path here. So each thread they are going to have separate path of execution here. Now you can observe this is the thread 1 and thread 2 and thread 3. Getting the point. So these are working simultaneously, or we can call it as a concurrently. But here, the separate path of execution is different compared to the each thread here. Getting the point. So this is the main advantage we are going to get when we are trying to work with the multi-threading concepts here. But if you observe, so as I explained here, so Java is already available with this particular multi-threading concept as a built-in process. Okay. Now, just we need to understand here. So what are the ways we can achieve the built-in multi-threading concepts here? Getting the point. So this is we need to understand very carefully here. Okay. And as I explained here, in all the modern operating systems, like if you are working with the Windows or Linux and in Mac operating system, so it's supported multi-threading concepts here. Because built-in, the each and every operating system is going to release with the help of the multi-threading concepts here. Cutting the plan. Now you can observe, basically we are going to have two types of multi-threading concepts here. One is a process-based and another one is a thread-based multi-threading concepts here. So we need to understand here the difference between process-based and thread-based here. Basically, the process-based, we are going to have some complexity in terms of the CPU utilization as well as objective creations. Getting the point. And as well as it's going to take the same path of execution for the all the remaining threads. So when we are going to work with the process based, getting the point. So come to the thread based here. So compared to the process based, it's going to give some additional benefits here. Right. So those are the benefits we need to understand here, like how exactly the process based is going to work. Basically, in the process based multi-threading here, what happens internally? Your program, like your computer, it needs to run with two or more programs concurrently. Getting the point. In the process based also, we have an option to run the particular two or more programs parallelly, right? But here, in the process-based multi-threading, it's going to enable run our Java compiler. So same time, we can work with any Notepad++ or text editor, or we can move on to any website to find out some information. Getting the point. So this is also we can achieve in the process-based here. But here, the program, when we are trying to run our program in the process-based thread, so it is a smallest unit of code that can dispatch by the scheduler. Compared to the other thread, it's going to release our program is the small amount of program is going to run in terms of our process-based or multi-threading here. Getting the point. It cannot access the more program code. Getting the point while running our program here, because this is one drawback we are having in our process-based multi-threading here. Right. Now we can observe. So in the thread-based, getting the point. So even though in the thread, it's going to dispatch the smallest unit of our program, and this means the single program can perform two or more tasks simultaneously. Getting the point. Now what you understand here? If you observe in the process-based here, so as I explained here, in the process-based, so the program can contain lot of code, but in the process-based, what it will do is going to take the smallest amount of the code. Getting the point. The smallest amount of the code, it can dispatch by the what's the scheduler. It can dispatch by the scheduler is nothing but, so based on the scheduler, the thread is going to run when we are going to work with our process-based here. But back to here, in the thread-based here, even though, so it's going to take the small amount of the program code, but in our single program, it's going to perform more than one task parallelly. Getting the point. In a thread base, if it is going to take small amount of our program code, but in the small amount of the code, it's going to perform so more than one, the task is going to perform simultaneously. Getting the point. So this is an advantage we are going to get when we're trying to work with a thread based here. Getting the point. But nowadays, all the applications are going to move on to the thread based here, because the processor heavyweight here. The processor heavyweight and it required their own separate address space here. Getting the point. It required to run any application using our process based multi-threading concepts here, what happens internally? Internally, those are the heavyweight tasks they are going to work internally, and what we can call it as a, along with it's taking the heavy weight as well as it's going to run their own address space. Carrying the point. Whenever the thread is started in the process-based application, what happens internally? So each thread is going to have the separate address space here. Carrying the point. As well as whenever we are trying to move one process to another, it's also very costly here. Carrying the point. One process to, if I'm going to move to the another process, so it's very costly to maintain the each processor here. Right. So back to here, when we are trying to work with the threads here, the threads are the lightweighted here. Getting the point. The threads are the lightweighted here. The threads can share the same address space to the other threads here. Getting the point. But in the process based here, each process can have their own address space. But same thing that cannot applicable in our thread based here. So the same thread can share the same address space to the other threads, and they are both the threads they are going to communicate very cooperatively here. Getting the point. And when we are trying to work with our inter-thread communication, so it's not going to expensive you. Right, we can call it as an inexpensive. So this is some advantages we are going to get when we are trying to work with our thread-based applications here. Getting the point. Now, how we are going to work with our thread-based application in Java. So this is we need to focus very carefully here, because we identified in the process-based applications here, we are having some drawbacks here. So first one is a heavyweight, and the process can have own address space, and when we are trying to work with another process here, so it is very costly here. Getting the point. So these are some drawbacks we are having here, and now, so instead of working with the process based here, now what we are doing here, we are moving into the thread based here, and using this particular multi-threading here. Now what we can do, we can write efficient programs here. So efficient programs here, if you have so simple, the example here, e-commerce website or banking websites. Getting the point. So when we are trying to work with the e-commerce website, when we are going to have one offer, getting the point. So the e-commerce website owners, they are trying to release offer on the particular item here. Getting the point. Something called 30% or 40%. Right. So what happens here? So we cannot understand here how many threads we are going to get, like how many users they are going to connect to their application to buy the specific item here. Getting the point. Now you can imagine. Now you can imagine here. Sometime they are going to connect the more than 10 people, or we cannot understand more than 100 people also. They will try to book the same item here, but we cannot give an option to the 100 users to book the same item here, because so we'll have a limited stock here. Once the stock is completed, getting the point. Some example, for example, we are having 100 items here. So once this particular 100 items is booked here, the users cannot understand here whether we are having the stock or can I book the item or not. So they will try to access our application here. Getting the point. But here the stock is completed, but we need to provide some message here. Right? So those information we can work with this particular multi-threading concepts here. So once we identified here, even though multiple users are connecting to our application to buy an item here, so internally we'll have some locking system. Based on some locking system here, now what we are going to do? So we are going to provide some messages once our limited stock is completed, so that we can achieve using our multi-threading here. So to create internally multiple threads, how we can work here with help of this particular multi-threading, we are going to work. So we'll see. So what are the ways we can work with the multi-threading here? But simple example we need to understand where exactly this particular multi-threading is going to work. Right. And along with this, we need to understand this some diagram here. So diagram is indicating here how this particular threads are going to communicate internally. Right. Now if you observe here, this particular threads, so it's going to suspended, or the threads are going to resume, or the threads are going to ready to stay here. Now you can observe, so initially we can call it as a red, so it's going to start. Like, so if you observe here, whenever our application is started, the threads also, well, like before going to start, getting the application is ready to start. When the application is ready to start, the threads also in the state call ready to start. Getting the point. Now here, ready to run. So this is one state here. And after this, now what happens internally? And once application is started, now we can call it as a here running. Right. When running thread. So if we want to suspend the thread, we have a option to suspend the threads here. Now we can suspend the thread. Suspended thread. So these are the states of the particular thread here. And after this, we can terminate the thread. We can terminate the thread. Cutting the point. Now we'll have a different states here. So we'll understand here how exactly the each thread, the state of this particular thread, we can understand here. Right. So we'll have a different methods in our multi-threading concept. We are going to have some of the classes here. So those classes we are going to understand here. So using those classes, we can easily understand. So whether this particular thread is in the which state here, whether it is running or suspended or it's ready to start the thread, getting the point. Now we'll see the status of this particular thread information. Just for understanding here, so what are the status we are going to have for each thread here. And along with this, we are going to have different priorities here. Getting the point. The thread can have different priorities here. So those priorities also we will see like what exactly the priorities we are going to have here. So we can call it as a main priority or non-priority as well as max priority. Right. So here now we need to understand here each priority. Right. So along with this, the priority, we are going to work with the synchronization. Carrying the pen. The priorities and synchronization we will see. So after completion of this particular single example here. And here, now what I want to provide here. So basically, when we are trying to work with the multi-threading here, we need to focus on the one class called thread class. So as well as we'll have a one interface called runnable interface. Let me open the interface first. This is the runnable interface. Getting the point. Now you can see we are having only one method here. We are having only one method. Now you can observe the method we are having abstract method here. So previously we already understand here when we are having this particular abstract method. Now what we can do? So whenever we are trying to implement this particular interface, so we need to override this particular run method here. Getting the point. Right. So whenever we are having a one method, so those interfaces we are going to call it as a functional interface. So we'll see regarding this particular functional interface later. But now observe carefully. We are having the one interface, and the interface can have only one method, run method. Now what you understand here? When we are implementing this particular runnable interface, we need to override this particular method called run, and we can define. So what are the logic we want to write inside this particular run method? Inside this particular run method. Okay. So when we are trying to write the specific code inside this particular run method, now we are going to achieve our multi-threading concepts here. Okay. So this is all about the interface class. And same way we'll have third class here. Getting the point? We're having third class here. So this is the third class. Now we need to understand. So basically, this particular third class now we can observe is implementing from our runnable interface. Right. Whenever the class is implementing from a runnable interface, now what we need to understand here, whether this particular run method, because we need to focus more onto the run method, how this particular run method is implemented. Now you can observe target here. So the target object is not null, they're calling here the target dot run. So what is this here, the target here? Now you can observe target is nothing but runnable. Right. The target object here, again, it is a runnable here. So runnable is nothing but it is an interface here. If the interface object is not null, so they are going to call run method. Okay. So along with this, so what are the other methods we are having here? What are the other methods we are having here? Now you can see, so these are the three priorities here. So as I explained here, min priority, num priority, and max priority. So what are the values we are having for these three priorities? Now you can see, so the min priority we are having 1, for the num priority we are having 5, for the max priority we are having 10. So these are the like these are the basic values here. Now we cannot exceed the max priority, or we cannot work with less than the min priority. So what between these priorities, like getting the point, between these three priorities, we can define if we want to create any custom thread with different priorities, we can go for between these the value. So 1 to 10, we can define the priority here. Right. Now, so we understood what are the priorities values here. And later, now what we need to understand here. So when we want to know what exactly the name of the current thread information, now what we can do, we can call here the method called current thread. We can call the current thread here. So this is the purpose of this particular current thread. It will give you some information regarding our thread class. So same way, so we are having different methods here. So these are the sleep method, right? On spin weight method and yield method. So this is our constructor. And now we already identified clone method. And these are the overloaded constructors. So these many overloaded constructors we are having here. Getting the point. We are having these many overloaded constructors. So this is a default constructor. So one is which is taking runnable, and runnable access control context. So one is which is taking the two parameters. So thread group and runnable. So name of if we want to provide any thread name, we can call this particular constructor. Right. So these are the different constructors. And same way, now you can see run method we already identified, start method. Getting the point. So start method. So start method basically to start our thread here. Getting the point. So after implementing these concepts here, now what we can do, we can start our thread here. Right. And so start method is a private method, and exit method also we are having private method, as well as we are having one more stop method. And now you can see whether this particular thread is getting the point. Thread is suspended or it is running. Now you can observe here the thread is live method. We can understand whether the thread is in the active or it is terminated or it is suspended. We can understand here, right? Or suspended, resume. So we can work with the priority here. Now you can see we are having the method called set priority. So we can go for to set the priority of the thread. So we can find out the get priority of the current thread. So name of the thread. Right. So same way we can work with the thread group. So we'll see. So what exactly this particular thread group will contain. Okay. Now just for understanding how many methods we are having inside this particular thread class. So each method is going to have a unique purpose here. Each method is going to have a unique purpose here. Now you can observe join method. Carrying one. So join and waits both are having the related purpose, but each method is going to have unique behavior. So we'll see. So each and every method. Getting the point. Each and every method we can understand here. Okay, so we'll continue with a simple example here. So to run with a simple example, now what we need to understand here, because we already identified. So to check with this particular multi-threading here, now what we need to do, we can go for the one interface or we can work with the thread class here. So we are having two options here, right? Now what I want to do, I will work with a thread here. Okay, let's see simple example here. So class I want to write with the current thread demo. Getting the point. So I am not creating any threads as of now. So just I want to know what is our current thread here. Getting the point. So without creating here, because I already explained here, Java having built-in support for the multi-threading here. So built-in support is nothing but we don't want to write much code. So we need to understand what exactly the default multi-threading concept is having. Getting the point. So in that case, now we need to understand what is the current thread we are going to run. Right. Whenever we are trying to run our application, so based on which thread the application is going to run. Observe here, I define the class and now I'm trying to work with so main method. So inside this particular main method, now what I'm doing here we're having a thread class, right? So if I'm going to call the current thread, because just now we understand here current thread, right? And here now if you observe carefully, I'm not creating an object. So without creating an object, I'm calling this particular method. So what you are understand, whether it is an instance method or it is a static method. The current thread is a static method or it is an instance method. If I'm going to call like this here, now what we can understand here, whether the behavior of this particular current thread, the current thread method, it is having like an instance, so it is having the instance behavior or the current thread method having static behavior here. Now what you are understanding here?
Yeah.
Yes, tell me.
So static behavior. So it's not the instance method, right? Static behavior of that.
Yes. So basically, if I'm defining, like if I'm going to open, now you can see, so static behavior. Getting the point. The method having static behavior. So we'll see later on this particular native keyword. So what exactly the native keyword? But now we can observe here thread here. This is the name of the method. Getting the point. But now what you understand here, thread. So thread it is a return type here. Getting the point. So previously we connected with our primitive data types here to return the some value. Same way we identify some of the method objects here. So for example, something. So which method we implemented to return the object? So constructor, some method we implemented to return the object here. So same way now we can observe name of this particular method. This is the return type of the method, and this is exactly the behavior of this particular method. It is a static behavior. So this is the way we need to understand. Getting the point. So all the concepts here, all the concepts we already implemented in our previous example. So one is the access modifier. So this is the static keyword. So same way we are going to have native keyword, but we'll continue the native behavior. So after completion of this particular multi-threading. But now back to this is the return type. So it is trying to return the class type here because we are inside the third class. So this particular method also returning third class object, name of the method. Right. Back to here. Now what? So why I'm calling this here, this particular method? So this particular current thread method is going to return the thread object here. The current thread method is returning thread object here. So whenever this current thread method is returning thread object here, so with the help of this particular thread, now what I'm doing here, I want to print here. Whenever we are trying to run our application, by default we are going to get one thread here. So to understand the current thread information, I am calling like this, right? And after this, what we can do, so we'll try to print the simple messages first. So we'll try to print the simple messages here. Okay, back to here. And Java say current thread demo.java. So it is a warning message giving file not found. What happened? Let me try. Okay, where we save? Where this particular class is saved? Okay, so we saved in the different location here. Okay, sorry. We need to move on to the D drive. In the D drive, we need to save. Now it is changed. Compile this particular current example. It is compiled successfully. Now it is running here. Okay. Now you can see what is our current thread. The current thread we are having main. So I want to know how this particular message is constructed. How this particular message is constructed here. Any idea? So if you observe, basically I'm trying to print this particular T. So T is nothing but reference of this particular thread class. Getting the point? T is nothing but reference of this particular thread class. Whenever I'm trying to print this particular T, we are getting this particular messages here. So previously, whenever I'm trying to work with a box class, here, what happens internally? We got some reference information, something called like this. We got information like so at the rate dollar some number again. Getting the point. So this is a message we received when we're trying to work with our custom object here. So that is called box or we created with the triangle classes because we understand the multiple example here. Box weight classes also we print the particular reference of the box weight object here. But now why we are not getting the reference information regarding this particular key? So I am getting this particular message here. Where this particular message is coming? Any idea?
So probably this is giving like that method name. Okay. So from where that thread is calling, right? So it's giving method name, and second one is 1, 5, 10 are there, no? Min priority, non priority, and max
No,
priority.
I'm not asking what is the information here. Just I'm asking here how this particular message, like how this open brace and close brace, so this commas and how the message is constructing.
Okay. So this is written type. Okay. The thread class, whatever returning, right? That thread class definition is there, no? So from there it is returning that written type.
Here it is the returning class object here. If it is returning class object, basically we need to get like this, because we are
Okay.
not calling the method here. So t dot get to name something. Just we are
Okay.
printing t here. T is a reference here. Okay, let's see. We'll go for the previous example where we created an object here. PC1 runtime method override hierarchical constructor shipment. Shipment. Okay. So if you observe system.out.println, here I'm printing CO. So CO is a reference of this particular constructor 3. Getting the point. Now Java C constructor 3.java. Now what happened here? Sorry, I did not save. Now you can observe here, when I am trying to print the reference of this particular constructor 3, we are getting this particular reference information. Right. Same thing I am printing from this particular, our current example. Here I am getting different message. This is I am asking here why we are getting here some message instead of this particular numbers here. Basically this number is indicating the objective reference here. Any idea? Okay. So here now we need to understand toString method. Getting the point? ToString is important here. Because in the constructor 3 we did not implemented any toString method. So same thing you can observe in the thread class toString method. So they are working with a thread, one open brace, name of the thread, priority, and group of the thread group name. Getting the point? Now you can see the thread we are having open brace. Later we are appending with the name of the thread. Now you can check with the comma. Right. So priority. Again we are having comma, group name, and closing the brace. Same information we are printing or not? The same message we are getting or not? Getting the point. Now what you understand here? The regarding the toString method. This is important here. Whenever like we want to print the custom message here, now what we can do? We can override the toString method. We can like whatever the way of message we want to print, we can define like this. So internally the thread class is defined like this. Now what you understand here? Thread is appending. This is the name of the thread. What is the name of the thread? Main. Getting the point. When we are trying to run our application from the main method, so one thread is going to start. The name of the thread we are having as a main. The priority we are having 5, and this particular main, it is a group name, thread group name. So we'll see what exactly the thread group name will have. Getting the point. And focus these two here. Getting the point. So we need to focus on these two sections. Name of the thread we are having main, and the priority we are having 5. Okay. So now what I want to do here, what I'm doing here, I want to change name of the thread. I want to change name of the thread here. So now you can see t dot set name, because just now we understand the set name method. Getting the point? Here I change with the thread name here. So whenever we change with the thread name here, now we'll print one more time here. Current thread demo.java, and now you can observe, because we are printing two times here, and before changing here we are having the main. After changing the thread name, now we can see main my thread. Getting the point? Now we understand the purpose of the set name method. So what is exactly the purpose of the set name method? So it's trying to set the name of the thread. It's trying to set the name of the thread. Okay, right. And after changing, we are printing the name of the thread. But if you observe one more method we are having here. So to understand, if you observe thread dot sleep method, here I'm trying to provide some milliseconds value here. Getting the point? Now you can see, first we need to understand the sleep method purpose. And here we are trying to work with the F method, and now you can see this sleep method is throwing one exception here. Getting the point? So now, if this particular sleep method is throwing an exception, so what are the two ways we can handle here? Can you please let me know if this particular method is throwing this particular exception here? So because we understood in the last class regarding this particular throws keyword, so we want to know now what are the ways we can define. I'm trying to work with the same sleep method in our example here. So if I'm not using here any exception information, so we'll see if I'm going to compile, so we are getting an exception. Now, how I'm release this, handle this particular exception. So directly, I'm unable to use the sleep method here, because while compiling the code, we are getting some exception here.
Try catch.
Okay. So can you please let me know the syntax is here? What I need to add in the try and what I need to add in the catch.
This thread dot sleep into try.
Okay. So whatever the catch here. So what is the exception we need to handle? Now you can read exception one more time.
Interrupted exception.
Yes.
So catch interrupted exception E.
Let me copy this particular exception. Right. Here I want to print some message. Okay. If I'm not handling with the try catch block, so do we have any other option to work with the same example without using this particular try catch? No idea?
Yeah, we can read through the exception like using throws keyword at main method level.
Yes. The same example, like if I'm not interested to use the try catch block, we can rethrow the exception at the main method level. Right. So this we need to understand very carefully here, because some method may throw this kind of exception, not only this particular interrupted, because we have a different types of exception. So it's going to throw when they are trying to throw. So this is the way we need to handle the exception here. Okay. Back to here. The example is compiled successfully. Now you can see, if you observe, after running this particular thread, we are having some this particular to print this particular message is taken some time here. It's taken some time to print here. So otherwise, what I will do, if you want to understand the purpose of this particular sleep method, now what I'm trying to write here, I will define loop here. Int I is equals to 0. So I less than 5 and I plus plus. And I'm trying to print this particular I value. But here we need to understand here how this particular I value is going to print. Now you can see I'm trying to compile one more time and it's compiled successfully, and I'm trying to execute this particular application here. Now you can see how the I values are printing here. Now you can observe how this particular I values are printing here. Getting the point. Now what you are understanding here? Why this particular I value is taking the time to print? Any idea?
Yeah, sleep method. So it's a waiting. That thread is waiting 1,000 milliseconds between each event.
Okay, which thread is waiting here?
So my thread.
Yes. So like whatever the current thread we are having, so that is called my thread. Getting the point. What is doing internally? Like we are making the current thread to sleep, so 1,000 milliseconds here. Right. So once the 1,000 milliseconds are completed, now what happens internally? So again, the thread is coming back to the running state. Getting the point. Now you can observe, initially the thread is in the ready to start stage. Getting the point. And whenever we are trying to print these particular messages here, the thread come to the running state. And here, using this particular sleep method, now what we are doing here, we are trying to suspend the thread some certain of time here. Getting the point. Now let me provide. Basically, we can understand this particular diagram here. So from here, ready to start. RS. RS is nothing but ready to start here. And here, it is running here. Getting the point. And here, it is suspended here. So when it is suspended here, and again, here it is running. Finally, it will go to the terminate here. Getting the point. So initial stage here. This is the initial stage. And whenever application is running, like whenever we are calling the main method, so along with the main method, the thread also is going to start. And when we are calling this particular sleep here, now what happens internally? the thread will become the suspended here. Some certain of time here, the thread is suspended here. Once the time is completed, again from the suspended to, it's going back to the running state. It's going back to the running state here. So from the running state, if the application is closed, it will go to the terminated state. Terminated state. Getting the point. So this we need to understand very carefully here how this particular thread is moving. So one state to another state here. One state to another state here. Getting the point. So this is very important here. And again, so we understand here the two methods here. First one is the name of the thread, like a set name. So we are trying to set the name of the thread here. So as well as, so we check with the current thread purpose here and sleep method here. Getting the point. So we understand the three methods information, the behavior of each method here. Okay, so back to here. So we'll find out the one more example here. We found out one more example here. And we understand, so any questions regarding this particular sleep method? So why this particular sleep method is throwing interrupted exceptions here? Why this particular sleep method is throwing an interrupted exception? So basically, when the thread is in the suspended, now what happens internally? So we may get multiple threads here. So while communicating with the multi-threading here, so some thread is going to like wake up the thread, getting the point. And now you can observe the current thread is in the sleeping mode, getting the point. So we may create one more thread here. Now what happens internally when one more thread is entered into this particular block of code here? Now what happens internally? So it will try to wake up this particular thread. It will try to wake up this particular thread here. And between what happens internally, if the time is not yet completed here, when the another thread is trying to wake up here, we may get interrupted because while sleeping, now we are trying to interrupt the current thread here. Right. So in that case, we may get an exception. We doesn't know whether so today we are going to get or tomorrow we are going to get. Right. So when we are going to get an exception, we doesn't know. So because of this, now what happens internally? So the like Sun Microsystem people provided the exception. Now what we can do? If I'm going to get any exception here, we are going to handle here. So maybe today we are going to get, tomorrow we doesn't know. But in future, if we get anything, we are going to handle. Now what you understand here? If you know, like if I'm going to open this particular interrupted exception, so directly, now you can see the interrupted exception is extending from which class here? Interrupted exception is extending from which class? Exception class.
Exception.
So if it is extending from our exception class, whether it is a checked exception or unchecked exception it is. Interrupted exception is a checked exception or unchecked exception.
Check.
Check.
Yes. So we need to understand one thing here. Basically, for checked exceptions here, at compile time only, we may get an exception. Getting the point. For checked exception, we are going to get an error at compile time. So, and the checked exceptions we need to handle like this. For checked exception, we need to handle like this, or we have another option, we can reflow. But now, what you understand here? Only the difference here, runtime exception, like unchecked exception, so they may get an exception runtime while executing the code. But here, the checked exception, while compiling the code itself, we are going to get an exception here. So if you observe, I want to define the same exception, like the same class inside our system. inside this particular package, I'm creating the same example. ID is not responding.
Yeah.
Here, I'm creating one same class with our main method. Okay, class is created. Same code I'm going to copy. And now you can observe what I will do. I will comment this particular entire code. Only I will enable this particular method here. So if I'm going to save here, so after completion of this particular billing workspace operation, now you can see, now what you understand here, whenever I'm trying to define this particular sleep here, they're getting an error here, getting the point. So IDE, while implementing the code, getting the any IDE, so whether it is Eclipse or NetBeans or any IntelliJ, any IDE, now what happens internally, while implementing the code, so itself it's going to give an error here. Itself it's going to give an error. So whatever the code we are writing here, the code is going to compile while writing our application here. But this is the one advantage we are going to get from the IDEs. But instead of working this particular IDE, now what I suggested here, basically if I am going to get this error, we can easily understand here. So what is a mistake I'm doing here? But now going back to this particular notepad plus here or any plus, what happens internally? While compiling the code, we are going to get an error here. So this is the difference we are going to get, because here we are not going to get any error while writing this particular application here. So this is some difference we are going to have with IDs and notepad. Now you can see, so what is error is giving? Unhandled exception type. Unhandled exception type with interrupted exception. So we are having the two options here. We can work with surrounded with try catch, or we can work with throws declaration. Now you can see I'm trying to work with throws declaration. So here we are trying to rethrow the same exception to the main method here. I'm trying to run the same example here. So let me proceed. Observe here. So current thread, the two information we are getting. Okay. Sorry. Missed. Here basically I want to print a message here. So this particular section of code I want to define outside. So this particular section of code I want to define outside here. So I value 1, 2, 3, 4. Okay. So here application is terminated. So this is all about the same example here. Getting the point. Only the checked exception and checked exception we can see. So for the checked exception, we are going to handle the exception at compile time. For the unchecked exception, we are going to get we are going to handle it runtime. Okay. For the unchecked exceptions, we are not going to get any error at compile time. This is all about the checked exception and unchecked exception. So back to our multi-threading concepts here. So we implemented one example with thread class. Now what I want to do, I want to check with the same example with runnable here. So to work with the runnable here, now what we can do? Getting the point. So what are the steps we need to understand here? Let's see the same example I'm going to implement. So I'm trying to work with the class, and here name of the class name I want to work with my thread. and which is going to implement from the runnable class, runnable interface, and here I'm trying to work with third class reference here, and what I'm doing here, I'm trying to define the constructor here. So my thread constructor I'm defining here, and here if you observe, so I'm creating new thread here. So creating new thread here, right? So how we can create new thread here? Basically, with the help of this particular t is equals to new thread, and we already identified we are having overloaded constructors. So in that case, I'm taking the string as a parameter constructor. Name of the thread, what is the thread name of the thread I'm giving? Demo thread. Getting the point. So this particular constructor we are calling with a string parameter. With a string parameter. Okay. So back to here. Now what I want to do, basically this is our child thread here. T. Getting the point. This is the child thread I'm printing here. And later, so we need to start our child thread. We are creating this particular thread object here, but this particular thread is not going to start here. So we need to call the method called start method. Now what happens internally? The thread is going to start here. So this is all about the information we are defining inside this particular constructor. So once we define this particular constructor, now what we can do? We need to override the run method here. So why we need to override the run method here? Basically, what we are doing here, we are trying to implementing from our interface called runnable. So any interface, if I'm going to have the method, now we need to override into the implementation class. Let's say this is our override run method here, and same I want to understand here. So whatever the code we implemented inside this particular current thread, let me copy the same information inside this particular run method. But here we need to understand here, so which thread is going to sleep. So which thread is going to sleep here? Okay, run method I'm closing here. And after this, after completion of this particular run method, now what I want to do, I want to work with itself only I'm defining it. So instead of going for the another class here, getting the point. So don't confuse here. The main method I'm trying to define inside the same class here. Getting the point. Now what I'm doing here, I'm trying to call my thread, right? So what is the constructor my thread? Getting the point. So I'm not doing anything here. Simply I'm calling my thread constructor. Right. After calling this particular my thread, I'm closing class level brace as well as method, main method level brace. And here I want to copy this particular same code here. Here also inside this particular main method. Inside this particular main method also, I'm copying same code here. So here, just explain me like what you are trying to understand, whether it is wrong or right. So that is different here. But just I want to know the answer, like what you are expecting here. Here I'm trying to sleeping the thread, and here also I'm trying to sleep the thread. And here line number 12, getting the point. So this particular line number 12, which thread is going to sleep, and the same way in the line number 22, which thread is going to sleep here. Just I want to know the answer, which threads are going to sleep here. And in the current example, how many threads we are creating here? How many threads we are running here? Not creating it. With how many threads we are running this particular current program here?
3.
Okay, can you please let me know how the 3 threads are going to run? Like from the where line number, like how we are explaining. How you think here? In the current example, we are running 3 threads.
First, and then we are creating the child thread T, and that main thread will sleep in line number 12, and in
Okay.
line number 23, I think child thread will sleep.
Here only 2. What about
But
other one? Yeah.
main thread is also there, right?
Okay, so here we are having the main thread. Okay. Uh, so here in the my thread constructor, how many threads we are creating here?
1.
1. Okay. So what about other one? So here we are having 2 main thread as well as 1 child thread. So just I need one more thread, like where the one more thread is came, like how the one more thread is coming.
Even in the starting we have, right, child thread.
Where?
Here T equals to new thread demo thread. This T.
Line number 5.
Thread T 2, yeah. 5 2.
Yes. Basically here now when we are calling this particular constructor only, we are creating the thread. Getting the point. When our application will run, this particular thread will not create. But when we are calling this particular constructor, whenever we are calling this particular constructor, itself this particular thread is going to create. Okay. So any other questions? Someone is trying to explain how many threads we are going to run, and what about this particular sleep? Just I'm trying to print current thread information. So in the both locations. Okay. So we'll see an example here. Java C mythread.java. So it's compiled successfully, and we're trying to execute this mythread program. Okay. Now what you understand here? Let me change the I value. So here also we are printing the same I value. Here also we are printing the same I value. Here we need to check with the main method I values. So that we'll understand here the I value is coming from where. Now if you observe, so child thread is created, right? So where we are printing this particular child thread, here we are trying to print this particular child thread, right? The name of the thread we are printing as a, like name of the thread as a demo, and we are copying by default num priority thread group same. So after this, now what happening internally? Main thread is creating here, and here, okay, thread is printing, right? So let's see, current thread also we need to change. So this particular current thread is printing from the run method, and this particular current thread is printing from our main method. Now I want to compile one more time. All are coming from the main method. So what happens internally? Why this particular child thread loop is not calling here? Anything we are missing? T dot start also we are calling. Basically, the run method is not calling here. Runnable is wrong. We define the same. Okay. So everything will be fine, correct. Type block, patch block. Okay. So let me try with the same example. mythread.java in IDE. By this particular, let me debug the code, like what happened internally. ID is not responding. Okay. So, like it's coming from this particular constructor we are calling, and the constructor is called here. So new thread is created. So we are starting thread here. So we need to wait. Okay. So what happened here? Only one thread is creating here. Okay. Basically, we are expecting two threads here. So this also it need to start here, but it's not starting here. Anything I'm missing? My thread. Created properly only. New thread with the demo starting. It has to call the thread.sleep. Start run method and the thread.sleep. Interrupted exception. Okay. So we'll work with this entire section creating with another class here. Let's see whether we are going to get two threads or not. Main thread. So once this particular thread is started, so we need two threads here. Let's see. So we'll wait a couple of minutes. No. Okay. It is not starting here. Only my thread is printing. Oh. Maybe it's because of 13 version. No. T dot start. Okay. So we'll see one more example with the thread class here. So I want to check whether the same example is going to work for the thread class or not.
So do we need to call run method explicitly?
No. It is so we are calling the start method. Basically, run method, if I'm going to call it, will treat it as a normal run method.
Okay.
Let me create a one more thread class here. We'll see from the thread class we are getting the true or not. We need to understand here. And this particular thread is going to extend from the thread class. Demo thread. And so start method. and okay. So we'll see. So putting a breakpoint here. Whether the new thread is going to execute or not. The debug we can understand. Yes. No. Okay. Run methods that are printing here. So these are about the run method. But what happened here while running the interface is not calling here. So we are expecting the same output like how we got here. Now you can see. So these are coming from the child. These are coming from the main. But the issue is not running from the our runnable interface. What happened? Dot start. Let's see. I will run one more time. Okay. Only main thread is printing. Hmm. Okay. So I will check this particular interface related example. So how we implemented here with help of this particular interface. So I need to check like what happening internally. So I will let you know tomorrow. And now we need to focus here. Now you can see by using the thread class. So using the thread class is nothing but we are extending the thread class here and we are having the one constructor. Internally I'm calling the super. Getting the point. So we already identified. So what exactly the super keyword is going to work. Getting the point. And I'm using the this here. So what happens internally this? So it will return the current class object. Current class object is nothing but thread class object only because we are extending from our new thread class from the thread class. So that not new thread also it will become thread class here. And we are calling the start method. Getting the point. So whenever we are calling the start method, what it will do? First it will check the same start method is available or not. Getting the point. If the available in the same class, it will call. So otherwise, it will call the superclass start method. So our aim to call the superclass start method only. We need to call the thread class start method only. Okay, let's see. Now you can observe if I'm going to run. So without the breakpoint. Without the breakpoint, now you can see how this particular example is printing here. So run method as well as main method. Run method as well as main method. The output it is a like adding both information. So child class thread information as well as main class thread information here. Now you can see. So this is child class thread information, and main thread is calling the loop one, and the main thread is calling internally I value 1. So this particular I value is coming from the child thread for loop here. And same thing, now you can see child class run method. Getting the point. So this is the way that this particular example is printing. But now there is no communication between two threads here. Getting the point. So this particular two threads not depending on each other here. They are trying to run parallelly. Getting the point. So this we need to focus very carefully here. Okay. So I will update you tomorrow regarding our runnable interface. Why the runnable interface example is not working here. So I need to check is something, because I'm expecting we are not missing anything here. But even though I need to understand here what happening internally. Okay. So any questions regarding our today's session? Except that one, the interface related example. No? Okay. So we'll continue on Monday with the another topics here, how we can work with multiple threads. So here we created only one child and one main thread. But tomorrow, like in the Monday class, so we are going to create multiple threads. So how we can work with two or more threads here. So that we are going to discuss on our Monday class.